So tonight we basically gonna do hypothesis testing. On Sunday morning. We will do a recap on hypothesis testing. So both sessions also recorded. So you can listen to both sessions at a later stage as well. Um, Another important thing nearly with hypothesis testing is how it links to confidence intervals and um, the sense of the things that what we test in confidence intervals in study unit 8, we're gonna apply a lot of that in study unit 9 as well. So we'll get to it, but you will see a lot of the same concepts coming through if we look at a Z value where we know what the standard deviation is. We will use a T value if the standard deviation is unknown. We will use a Z when we look at proportions. So that work that we did in study unit 8, we're going to apply that again in the study unit 9. So I think again study unit 8 and 9, um, and that's why they also group it together for your assignment, um, is because there is a very very good link between the two study units. So tonight we're going to look at hypothesis testing. We'll recap on Sunday morning again on hypothesis testing. Then next week, Tuesday and Thursday, we will do prep for your assignments. So I don't think the mock assignment will be ready by then, but I will use one of the previous assignments to look at that. Okay, so the important thing with hypothesis testing is that, and again, I'll share the slides, but this is also in your study guide, is nearly to follow a few steps. So we had the same when we looked at confidence interval. We basically followed a few steps that we needed to do. So hypothesis testing, the same. So we will look at nearly 10 steps, but some of them are actually grouped together also. So it might be when we look at it, it's actually a bit less. So the first thing that we will look at, and we'll highlight that in each of the questions as well, is we look at a null hypothesis. So that is the hypothesis that we believe is true. So if we test for, and we say that we test for that the mean of a sample is something, we believe that is the mean. So the alternative hypothesis will be to say, but hang on, we think you are not right. So the null hypothesis is about, that is what we think is the current situation. And your alternative hypothesis is the one that we say, we believe you're not correct. So we believe there's something opposite to that null hypothesis. what you will see in the null hypothesis is that we will have, and let me quickly just get to, so the null hypothesis we will have as an equal sign. So you will always say with null hypothesis that the mean is equal to, and let's say 50. So your null hypothesis will always be that we will say the mean is equal to 50. Your alternative hypothesis will say that, okay, it is not 50, but we can say that in a few words. So we can say that your alternative hypothesis is not equal to 50. So that means that it can be bigger or it can smaller than 50. We can say, well, your alternative hypothesis is bigger or equal to 50, or we can say your null hypothesis is smaller or equal to 50. Okay, so there will always be a null hypothesis and alternative hypothesis, and they need to tell you. So it might be that they give it in this format, or it might be that they use words, and we will then go back to this table that I've included nearly in all our discussions thus far, so that it might be that they say something in words and we would need to basically look at what the symbol is so that we can answer that. So first thing nearly is that we will have a null hypothesis and alternative hypothesis. Then the second one that nearly also goes together is step 3 and 4. So where we look at levels of significance. So again, linking to what we did in the previous study unit of confidence intervals. So remember we said we used things like a 90% confidence interval or 95% confidence interval. So where we go with level of significance is basically that 1 minus the 90% will give us a 10% level of significance. 1 minus a 95 will give us a 5% of level of significance, and the 99% would have given us a 1% level of significance. So again, just to bring the two study units into context with one another. So the level of significance is for alpha. We used it also when we look for if we are going to go to the t-tables in a question. That is also level of significance is there in the next study unit, in study unit 10, when we look at chi-square. We will also look at the level of significance in that component. So just very important, level of significance. What they would normally tell us is the level of significance is 1, 5, or 10%. Okay, so at least they will normally communicate that with us if we need to work out something that is required. Then the the confidence coefficient that you can now see links to where we had the confidence interval. So the 1 minus alpha times 100%. So if it was 1 minus 1%, we will get to the 99. If it was 1 minus 5%, we'll get to the 95. If it was 1 minus the 10%, we'll get to the 90%. So again, just the link between those two. And then so basically we get now to, we've done the hypothesis. They tell us this is the level of significance, but then we need to work out if that is going to be true or not. So what we're going to do is we're going to work out, and we should actually have this critical value a bit earlier. So we're going to work out a critical value. Then we're going to decide, okay, I'm going to accept the null hypothesis, or I'm going to reject it. So is it what I worked out? Is the mean really 50, or is it not 50? So that is going to be where we will look at the acceptance value or the rejection region. Another thing that is important is, do we deal with a one tail or two tail? Because that will also influence what the critical value will be. It will also influence what alpha we work with. There's only one place where it is a two tail, and that is when your null hypothesis is equal to, and your alternative hypothesis is not equal to. So that is the only place, and the only example of when we deal with a two tail is when your alternative hypothesis is not equal to. When we deal with a one tail is when it basically tells us that we're dealing with something that is bigger, something that is smaller, something that is bigger or equal to, or something that is smaller or equal to. So only time that we have a two-tail is when the alternative hypothesis is not equal to. All the other times we will have that we are dealing with a one-tail. Okay, so we will go through exercises now again to just show you how it is done as well, why it is important, and things like that. So just again, the 10 steps, and you can, and I will reshare, because I think there has been a few students that have joined after I shared my summaries. So I will just share again tonight my summaries of hypothesis testing, how that also looks on a summary page, so that you guys can also see how I will use again, the normal distribution picture that we've drawn in chapter 6 and 7. I will pull that into the work that we will be doing tonight as well. Okay, then just one thing again, for a Z test, so for where we know the standard deviation and where we work with proportion, we will use the Z test. And then just like in study unit 8, we can assume a few things. So if we work with a 90% or 1% alpha, we can say a Z of a two-tail is 2.58. A Z that's a one-tail is 2.33. If we work with alpha of 5%, we have the values, and if we work with alpha of 10%, we have the values. So again, that table that we used in study unit 8, we're going to use that in study unit 9 again, because those are standard numbers. Again, they will not ask you in the exam to work out where alpha is 3% or 6% or 7% or something like that. It is the standard free that we will work with. So 1%, 5%, and 10%. As in study unit 8, there's also the one that standard deviation is unknown. So a population standard deviation is unknown, where we will need to work with a t-stat. So then again, what is important, we will need to get the degrees of freedom and for alpha divided by 2. So as you see, that is basically what we reference with Z as well. But again, they will tell you work with a significance level of 1% or the 5% or the 10%. So again, they will not use different levels of significance, because that is again what we will see in the Z table. So let me quickly just show that Z table again, so that one can just make 100% sure. And again, if I need to share this with you guys, this was your TUT letter 101. So where we go to the end, there's all the tables. So again, when we get to the T table, and I might now have missed it. So let's just quickly check. That's the Z tables. Okay, so that is the T table. So let's zoom in again. So here you can see that they talk about that area as your alpha, and then that is your alpha. So that is for alphas that they can give you. So the 1%, the 5%, the 90%, they don't really do the others, but if they do give as a 99.5%, it is there. They will not do the things in between. So just again, they will not give you something different to what is available in the tables. So again, very critical, that component, that they will not give you something that you don't have access to. Okay, so let's do a few examples. And normally how I look at it is I look at and some really basic writing errors in this one. So that must be um, H0. So you can see the null hypothesis is equal. The alternative hypothesis is not equal. So not equal means two-tail. So that is nearly the first thing I will look for in the option. So which one is incorrect? Another spelling error. So a two-tailed is used. Two-tailed is used. Yes, because the alternative hypothesis tells me it is not equal to. So because it's not equal to, I can use a two-tail. Okay, so okay, this is interesting. The standard error is 20. So let's look at how do we calculate standard error. So now, again, it is work that we've done in chapter 7. If we look at the formulas, um, we will use that formula that we've done in chapter 7. So standard error is the bottom part of the formula. So let's first see, okay, we're working with a Z because the population standard deviation is known. So standard error is, as we did in study unit 7, the standard deviation, which is 200, divided by the square root of n. The square root of 100 is 10. The 200 divided by 10 is equal to 20. Okay, so that is also correct. So we see a lot of the work that we've done in previous chapters um, being included in this chapter. So again, very important nearly to go back to that study unit 6 and 7 to understand and to assist within this chapter. Okay, the test statistic that we need to work out. So that is again that formula that we're going to use. So the same that we did in study unit 7. So we've got the Z is, and let me just make 100% sure. And we divide it by the standard error. So we already know that the standard error is going to be 20. They normally don't ask both, but it's fine for this one. We can use it, but they normally don't ask both standard error and the test statistic because you actually use the standard error in both. Then our X is 980, and we test it against hypothesis that 1,000 is very similar to the 980. Okay, so that will give us at the top minus 20 divided by 20, which gives us minus 1. Okay, so again, very easy to make the mistake to say minus 1 minus 0.1. if you read it off the calculator incorrectly, but that is the incorrect answer because we actually have it as -1 because -20 divided by 20 is equal to -1. Then just some other things. Critical value. So the critical value where alpha is equal to 0,01, where it is a two-tail. So we can use the table out of your study guide. So let's just quickly go to it. Alpha 1, where it is two-tail, we see that Z is 2,58. Alpha 1%, where it is two-tail, 2,58. Okay, so again, you don't need to now go to a different table. You are able to do it from that small table we got in the study guide. I just want to show you if it was now a t-test that we worked with, we still got the 0,01 as alpha. So remember, if it was a t, we would have needed to do degrees of freedom and then alpha divided by 2. So degrees of freedom would have been 100 minus 1. So degrees of freedom would have been 99. And then that would have been, what is 0,01 divided by 2? Where's my calculator? My brain is not functioning that good today. So let's quickly check because it will make a difference on the table as well. That is 0,005. So if we needed to use the t, which not needed in this one, but if we needed to, we would have gone to degrees of freedom of 99. Hopefully there is one. Degrees of freedom 99. And we would have gone to 0,005. And you'll see as we get closer to and how bigger the sample becomes, so very close to that number we got from the Z table. If it was a massive sample, it will really become like a normal distribution. But if you needed to use the Z, there was the 99, sorry, the T table, and with the 0,005, we would have gotten a T value of 2,6264. Okay, so I just wanted, even though we did not, it is not a T, if you needed to get to it, that is how we would have gotten to it. Then the last one is that they will ask you, and most of the questions will include that, is do you reject or do you accept the null hypothesis? So let's quickly check, and that is where I love to draw the normal diagram. It is also in your study unit. But what we will see is if we have the critical value, we have that is 2.58. We've worked out the Z value is -1. So if we have that the critical value is bigger than your Z value that you have worked out, so then we will reject the null hypothesis. Okay, so let's just quickly, and that wording is different that we're using now. So let's just quickly, so if the T-stat is smaller, than your critical value, so we will actually accept. So let's just see what is happening with this one. We will accept the null hypothesis. So reject the null hypothesis when the p-value is less. Okay, so when you're, and this I will explain a few times today. So when your T-stat is smaller than your critical value, we will accept the null hypothesis. When your p-value is less, we will reject the null hypothesis. So let me show you on this table, and let's copy this. I want to make space for this. So because this is important in this instance. So that is your p-value. So your p-value of your critical one, the 2.58, we actually, that was 0.01. So we have it from that table. But if we go to the T-stat of -1, and we always use the positive values of both. So let's look at that T-stat. So there you will see the p-value of that T-stat is much bigger. Okay, so your p-value, if we look at it from the point of view of a T-stat, is a bigger area. So we will reject the null hypothesis if that blue area is bigger than your black area, which was a critical value. So the two things that is important is when the T-stat is smaller than the critical value, we'll accept the null hypothesis. But then when your p-value is smaller than your, and let's use it, sorry, not, I wanted to say the p-value of your critical value, but let's call it as it is for alpha. So if your p-value is when okay, so that is how the two will work. So in others, we will be asked to work, and this is very confusing when we first deal with it, because sometimes they ask you the critical value, if that is bigger. Sometimes they ask you about the p-value, so they use it interchangeably. So I will share with you some theory again on this, that you can see the differences in the two methods. I will also share my summary page that I have done with you guys as well. I've drawn it out so that you can nearly see both instances. So again, it's important because the next question might be that they ask just around the t-stat and the critical value. Okay, so let's go to the next one and see how they frame this one. So null hypothesis equal alternative hypothesis bigger than one tail. Okay, so that already is the first thing that I notice. Okay, so let's look which one of following statement is incorrect. Okay, one tail is correct. Again, the reason why one tail is because it's one directional. It is a bigger than sign that we have this time. Then what else do they give us? Okay, this is interesting. So we don't get a standard deviation. Was the standard deviation left out? So let's just quickly, and maybe it's not needed. So let's quickly check one tail. That already tells me that we've got the mean. Okay, alpha, if we deal with one tail, 0,05. So let's quickly go back to one tail. Alpha is 0,05. One tail, so it will be 1,645. Okay, see, so now I am worried that here is two different views. So they ask us the critical value at 2,5%. So they've mixed up this question a bit. Critical value at 2,5%. So it is 5%. It's definitely not that. I don't know what that is because I don't know what that is. Phew. Let me just quickly check where I got this question from. because there's a few things that is not included here that I need. So I definitely need to know if it is a Z or T that I'm working with. So if it's a sample standard deviation or if it is a population standard deviation. So that is critical. It's weird that that wasn't included unless, again, it was one of those that was just eliminated and really not um, in covered. So let me just make 100% sure why this is like that. So let me quickly just check the question. Okay, so what was left off is that we actually have a standard deviation, a population standard deviation of 10. Okay, so that has been left off. So, okay, so that makes a big difference. So before we get to critical value, let's work out the T-stat. So the T-stat is standard deviation, because I want to, again, when we get to those two, I want to explain it all together. So let's quickly work out the Z. So it's the X, which is 53.5, minus 50 divided by standard deviation of 10 divided by 64. So again, if in your assignment there is something like this happening where you don't have, or one of the measures was not included, please you guys can always WhatsApp me and tell me, because I know in the previous um, assignment there was also something missing, and then they will drop the question. Okay, so we've got 53.5 minus 50 is 3.5, and if we divide it, 10 divided by the square root of 64, which is 8, we will get 1,25. So 3.5 divided by 1.25 is equal to 2.8. And so that we know is correct. Then just the critical value of the 2,25. So now this is interesting. We've got the critical value of a 5%. We don't have a critical value of 2.25%. Okay, so let's work that out, and I want to show you how to do it. Again, we will not get something like this in your exam, but again, assignment wise, they do this sometimes. Um, so we go to the Z table, and since we have a Z equal to, let me quickly, where they say the alpha of a critical value of 2,25. Let's draw that. So one tail, we get that is 2, oh, sorry, why did I say 2,25? 2,5%. So if we look at what is on the left-hand side, that is 97.5%. Okay, so that is going to be our critical value that we're going to look at. Critical value, they said, there's for 2,5. So we're going to look for the 97.5. I don't know why I said, can see my antibiotics kicking in. So let's just quickly check. So let's go to the Z table, that we can see what is the critical value of that. So the easiest one is the positive Z. We look at the positive Z of 97.5. So look, 97.5. Okay, so 97.5. So let's look what it is. 1,96. Okay, so there we have that area as the, okay, it doesn't want, so let's quickly see if I can at least write something. So we said we're looking for 97.5%. That is the 97.5. That 97.5 is 1,96. So the critical value at 2.5 is 1,96, which is correct. But now I want to show you again where it is as 1,96. Okay, so again, very important, even though we say it's the two-tail, that was 95%. We were looking at 97.5. So there's a few things that I will add for you guys onto this, so that if something like that happens in assignment, we have that. So if we deal with a 2.5% alpha, then we know the one tail is actually going to be 1,96. So I will add that for you. Let's quickly do that now. If we do the 2.5%, the one tail will then be 1,96. Okay, so option 1 correct, option 2 correct, option 3 correct. So let's look at the fourth option. And here they say the p-value is equal to 0,0052. Okay, so let's again, we worked out what the t-stat is. The t-stat was 2.8. So that value should be the p-value. So again, we can go to the Z table, where we look at Z positive 2.8, like we did in study unit 7. But then we get this area, so then we need to say 1 minus, or we can go to the negative table of 2.8, and let's see what is our Z value there, 2.8. So negative 2.8, 0.026. So that p-value is equal to 0.0026. Okay, which then tells me that this p-value is wrong. If we dealt with a two-tail, then on this side, there would have been a p-value as well. We're not, so then we keep that p-value is only to do with that part because it's a one-tail. One-tail tells me we're only looking, and again, the bigger, we're only looking at that area bigger than. That area bigger than is 0.0026, which tells me that the p-value is incorrect. Okay, and then let's look at your p-value of 0.0026 is smaller than 0.2 or 2.5%. So because that is smaller than 2.5%, we will reject the null hypothesis. Okay, so because the p-value is smaller, the p-value is smaller than the alpha, the p-value is smaller than the alpha, we will reject the null hypothesis. Okay, so again, important, this component. So I will again share a page with you guys that has the t-stat and the p-value combination so that you can just see. But again, p-value smaller than the alpha, so we will then reject the null hypothesis. Okay. It's a lot. I think one of the most difficult chapters is the study unit, because it combines study unit 6, 7, and then a bit of study unit 8 into this new concept that is hypothesis testing. So that's why, specifically for hypothesis testing, we will have another session on Sunday, and then when we do, we will actually next week then do 2 recaps of study unit 8 and 9. And when I don't know when your assignment is due yet, but I do think that we will do another recap on study unit 9 specifically before your assignment is due, because hypothesis testing is one of the most difficult study units in this study that we are doing. Okay, then a few definition type of questions as well. So let's look at a professor of statistics refuses the claim that the average student spends 3 hours studying for the exam. Okay, so his claim is that um, students are not studying 3 hours. He's not saying more than 3 hours, less than 3 hours. He's just saying he is sorry, but he does not believe that students are studying 3 hours for the exam. So your null hypothesis or your alternative hypothesis is not equal to 3. So he says students are not studying, so null hypothesis not equal to 3. So let's first look at all the null hypothesis. So bigger than 3, he didn't say bigger than 3. So let's not equal to 3, so that can be equal to 3. No. Smaller than, no. Not equal to, yes, but we're not dealing with a sample. It's a population. So that's incorrect. So the only one that is correct is option 2. And we know that if that is not equal to, your null hypothesis will be the one that says it is equal to. Okay, so null hypothesis is your mean is equal to 3. Your alternative hypothesis is that the professor refuses to believe that students are spending 3 hours. Okay, if it was students are spending less than 3 hours, then option 4 would have been the correct one. If it was students spending more than, but then that needed to be equal to. Okay, so if it was spending more than 3 hours, then our null hypothesis would have been still, we believe it's 3. The professor says no. He believes students are spending more than 3 hours. If it was less, then the null hypothesis would have still been equal to, but your alternative would have been no, students are spending less than 3 hours. Okay, so that is just a bit of definition that they introduce to check if you know what the null hypothesis is versus the alternative hypothesis. Okay, and then another theory question. So which one of the following statements is correct? And then they ask us about the hypothesis process. Okay, so in the hypothesis process, you should define the statistical hypothesis, null and alternative. Yes. You need to determine the region of acceptance. Yes. You need to calculate the test statistic. Yes. And you need to compare the test statistic to the critical value. Yes. So actually, all of them are correct. Okay. When you go to your study guide and your textbook or going online, you might also see that they love to use, instead of H1 as your null, your alternative, they might also sometimes have that they call it HA. Let's just write it bigger. HA, because they say alternative hypothesis. So just remember that the alternative hypothesis can be written as H1, or it can be written as HA, wherever A represents alternative. Okay, so again, just something that you might see in the textbook, or when you Google something that might come up. Okay, so let's look at another question. So this one a bit different. So here they ask us calculate the p-value of a test statistic or of a test of the following hypothesis, given that the sample proportion is 0.63. And what they tell us is we're going to test it where the alternative hypothesis is bigger than 0.6. Okay, so that tells me we're working with a one tail. So what we're going to work out is we're going to work out the Z value. Then whatever we get is going to be a one tail. So that one tail is only going to refer to that, and that is going to be our p-value. Okay, so we're going to work out your p-value with the Z. The Z is as we had in study unit 7, but let's just quickly check again. There is the Z, so P minus, so let's quickly write that down. So again, nearly important of study unit 7 that comes in here of proportion. So let's quickly see. The P is 0.63. And we're testing it against 0.6. And then below the line, again, the ones that has better calculators than I have, I think you can do it nearly in one step. So 0.6 times 0.4, that we will need to divide by the sample size, which is 100. If we take the square root of that, we will divide it by 0.049. So 0.03, because 0.63 minus that is 0.3 divided by 0.049. Sure. Hopefully will give us a number that we can work with. Okay, so I get 0.61. So that is my Z. I hope that is correct. So if that is 0, this is going to be much bigger area actually. The Z is going to be there, 0.61. So I'm just moving it so that it does not look weird, because if you look at that answer, it's probably also going to be a big area. Okay, so again, now we can, like in study unit 7, can do it two ways. We can go to a negative Z, so minus 0.61 to get that area. So minus 0.61 to check 61 years. So 0.2709, which does not seem right. So I'm wondering if I made a mistake there. So please, if anybody else worked it out differently, please let me know, because I'm now not getting the same answer that I was hoping for. So I just want to check where I made a mistake in my calculation, because this does not seem right. I read it wrong. Okay, but this is also interesting, because that and that should have been the same. Okay, so they actually give us the Z value. Look at that, they give it to us. So this one that we calculated, even though it is, I think it is correct, they have given us the calculated Z value. Okay, I have not read that correct at all. So this should not, we should not have even done this. And now I get a different answer to what was there. So that's why I thought, what is going on? Sure, I didn't need to do any of this, because they've given us the Z value that we, so they told us the calculated one is 0.05. Okay, so I just did a lot of work, and it was not needed at all, because they told us Z is equal to 0.05. Okay, Z is equal to 0.05. So again, we can go to the negative table, 0.05, and it is 0.4801. So that is 0.4801. Sure, okay. Which is option 1. So totally misread this. They told us Z is equal to 0.05. So we could have used that Z as 0.05. It's actually scary that when you calculate that, it is not the same. Yeah, it's actually scary that it should actually be the same. So so I will again just go and work it out, so that even if you work it out, that you still need to get that Z. So that for me is a bit scary that you don't get it, because again, yeah, I did not include that in my reading of a question. But if you missed that, you should still get to the Z equal to 0.05 by working out the Z. Okay, so I will just again check this one if I not have made a mistake with calculating that Z, but it should at least be closer to your 0.05 that they've given us than what we got to. So a very valuable lesson in this one. Read the whole question, not just like I did. I did not even read that at all. I just looked at the P. I looked at that. I looked at that 100. I wanted to work out the Z because that is what I was supposed to do, and not even realizing that they've given me the Z, so that I don't need to go that process. Okay, but I will just check for you why it did not also work out, because it is supposed to actually work out even if you missed it. Okay, then the last one for tonight. So again, we get the 4 or 5 things that they want to test in hypothesis testing. So the first one, they're asking actually the 2 hypotheses. So let's read it. A popular weekly magazine asserts that fewer than 40% of households in South Africa have changed their lifestyle because of escalating gas prices. Okay, so they actually tell us in that first one, fewer than. So null hypothesis is alpha is equal to 40%, so 0.4. The null hypothesis was that. The alternative hypothesis is fewer than. If we go back to that original table that I shared, fewer than, exactly the same as less than. So it's that smaller sign. So again, why I've included that. Less than 0.4. That is correct. We are unfortunately looking for the incorrect one. Okay, so let's see what else. A popular weekly magazine asserts that fewer than of households in South Africa have changed their lifestyles because of that. A recent survey of 100 households find that 67 households have made lifestyle changes. Okay, so that tells me that the P is 67 out of 100, which is 0.67. So we will need to work out a test statistic. So let's first also see critical value. If we go to critical value of 10%, where is my table? Critical value of 10% of the one tail is 1.28. Critical value of alpha of 10%, remember we're working with a one tail, is 1.28, so that is correct. Okay, so now unfortunately we will need to work out the t-stat. the test statistic. So let's hope that this one, it is working. So 0.67 minus 0.4 divided by 0.4 times, and let's rather say 0.6 divided by 100, the square root of it. Okay, so let's see if I this time work it out correctly. 0.67 minus 0.4. So at the top, it's minus, or sorry, 0.27. And at the bottom, 0.4 times 0.6 divided by 100, the square root of that. So I get 0.049. And then if we work that out, I get 5.51. Okay, which is also that. Okay, so at least those three are correct. Then to look for Z value, so Z value of 5.51, and we want to get that p-value. Sure. Okay, so Z 5.51, I don't even think that is on the tables because it is so big. So you can see there is Z5, so 5.51, they don't even, because look at that, 0.00000, so 1, 2, 3, 4, 5, 6 zeros. So if we look at 0.0000, so we can add more zeros. So that is very small. So let's, just for interest's sake, let's Google it, what the answer would have been, because again, it is very small. So let's do p-value. So let's do a p-value calculator. I just want to see the one that I normally like to use. Okay, so there's not one now, but let's just, so p-value from Z, we got it as 5.51. Okay, so you can see they even say the two-tailed. Okay, did we specify one or two tails? They didn't even ask in this one, so then I don't like this one. So let's quickly check another one. P-value for Z-score, 5.51. It was one tail we tested, I think, against that. Let's see. Okay, and where they say p-value is smaller than 0.0001. Okay, so what I am going to do is include this in the chat, that if you want to test, you can can use that one. I am also going to put it in the notes. Okay, so let me question. It's now nicely in the chat, so I will delete the previous one. And there is it for you if you want to go and check it out. Okay, so p-value is very small. So that is also correct because it is really 0,000. So then they say conclusion, the null hypothesis is not rejected at the 10% level. Okay, so let's now look at the two options. So T-stat so there's your T-stat is bigger than your critical value. So when your T-stat is bigger than your critical value, so let's just show that again. T-stat is bigger than your critical value. We reject the null hypothesis. And so remember, T-stat bigger than critical value, we reject it, like we said in some of these. Where was it? We did it the other way around. But then also, let's just say it from the p-value. If we see that the p-value is smaller than your alpha, your p-value was 0,0000, and when we actually looked at it, it's much smaller than that even. So when your p-value is smaller than your alpha, and your alpha was at 10%, which is 0,1, that is also when we reject a null hypothesis. Okay, so those two, when the T-stat is bigger than critical, we reject. When your p-value is smaller than alpha, we reject. And that's why they say the null hypothesis is not rejected, is the incorrect one, because we are rejecting the null hypothesis. So in this instance, we can clearly say that the sample mean is different from the population mean, or proportion, sorry. The sample proportion is different from the population proportion. Okay. So I will write these up a bit as well. And I will also, I've got it again, a PDF of a theory that I will share, but I will only let me share that after our recap session on Sunday. That we just do this one more time. Again, this is, for me, hypothesis testing is the most difficult chapter of this study unit. Or of this course. So, because there's a lot of new things that one needs to grasp in this study unit. So we will definitely have a recap on Sunday. Then next week on Tuesday and Thursday, we will basically do